Welcome to Across the Globe. Today, we will learn about password hashing and security practices. Password hashing is a crucial practice in cybersecurity that involves converting a password into an irreversible scrambled form. This process enhances security by obstructing unauthorized entities from easily retrieving the original password. By employing secure password hashing techniques, such as using cryptographic algorithms like bcrypt or script, organizations can safeguard user data from potential breaches. This extra layer of protection is essential in preventing password cracking activities and fortifying cybersecurity defenses. An example of this is when a user enters their password on a website. The password is hashed before being stored in the database, ensuring that even if the database is compromised, the original passwords remain inaccessible to attackers. Passwords stored in plaintext are vulnerable to theft during data breaches, as they are easily readable. To mitigate this risk, passwords should be hashed before storage. Hashing means converting passwords into a jumbled series of characters using cryptographic algorithms. This ensures that even if a hacker gains access to the database, they can't retrieve the original passwords. Django, a Python web framework, simplifies password hashing by offering built-in functionalities. When a user creates an account and sets a password, Django automatically hashes it before storing it in the database. For example, a user might set the password secret password. Instead of storing it as is, Django would hash it into a string like AVRA5E6B78. By using Django's password hashing capabilities, developers can enhance the security of user data, reducing the risk of unauthorized access to passwords in the case of a data breach. Password hashing in Django is achieved through the makePassword method from the django.contrib.auth.hashers module. This function securely hashes passwords for storage in databases. Subsequently, the checkPassword method is utilized to compare a given password with its hashed counterpart to ascertain if they correspond. This practice enhances security by safeguarding sensitive user credentials. By applying makePassword in Django, clear text passwords are transformed into cryptographic hashes, strengthening data protection and minimizing security risks. To hash a password in Django, import makePassword from django.contrib.auth.hashers, then specify the password to be hashed, followed by calling makePassword with the password as an argument. Finally, store the resulting hashed password in a variable for potential database storage or other operations. This methodology ensures passwords are obscured, fortifying cybersecurity measures encompassed within Django applications. In practical terms, consider a scenario where a user registers on a website and creates a password. The website hashes the password using makePassword before storing it in the database. In recurring login attempts, the stored hashed password is compared to the user-provided password hashed via makePassword using checkPassword to authenticate access, instilling a protected authentication mechanism. To ensure secure password storage, strong hashing algorithms like bscript or Argon2 should be used. These algorithms create a hashed representation of a password that is extremely resistant to decryption. Additionally, it is crucial to use a unique salt for each user. Salts are random data strings added to passwords before hashing, making it difficult for attackers to use pre-computed rainbow tables to crack passwords. Furthermore, staying abreast of the latest hashing algorithms and security best practices is vital to thwart emerging threats and maintain robust password security. By applying these measures diligently, organizations can significantly enhance the protection of user passwords. Password hashing is a critical security measure for safeguarding user passwords in web applications. Django, a popular web framework, offers convenient built-in functions for password hashing, streamlining the implementation process. Adhering to recommended practices in password hashing fortifies user data against potential unauthorized breaches. For instance, imagine a scenario where a hacker gains access to a website's database with unhashed passwords. This breach can expose sensitive user information. By utilizing Django's password hashing functionality, developers can significantly enhance the security of their web applications and prevent such security vulnerabilities. Imagine your password is like a secret code to enter a locked safe. Password hashing is like converting that code into an unbreakable cipher that only you can decode. Implementing security practices is like adding extra layers of protection around the safe, like alarms, locks, and guards. Converting this analogy into a program would involve using encryption algorithms to hash passwords and incorporating security measures such as two-factor authentication and regular security audits. Hey, code conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The provided code snippet showcases the implementation of password hashing and security practices within a Django application. The register user function handles user registration by hashing the password using Django's make password function, which securely encrypts the user's password before storing it. This ensures that sensitive user data, such as passwords, are not stored in plain text and are protected from potential security breaches. Once the password is hashed, the function prints the username and the hashed password for reference. During user login, the login user function compares the hashed password stored in the database with the password provided by the user using Django's check password function. If the passwords match, the function notifies the user that they have successfully logged in. If there is a mismatch, indicating incorrect credentials, the user is alerted that the login has failed. Furthermore, the code demonstrates the integration of additional security practices such as two-factor authentication function, and security audits, security audit function. Two-factor authentication adds an extra layer of security by requiring users to verify their identity through a secondary method, strengthening the overall authentication process. By initiating a security audit, the application can proactively identify vulnerabilities and detect any unauthorized access attempts, enhancing the system's overall security posture. Overall, this code exemplifies the implementation of password hashing and security best practices in a Django application, highlighting the importance of safeguarding user credentials and maintaining robust security measures to protect sensitive data from potential threats. An industrial example that utilizes password hashing and security practices can be found in the banking sector. Banks utilize password hashing techniques to securely store and verify customer passwords. When a customer creates an online banking account, the bank's system hashes the password using a strong hashing algorithm before storing it in the database. During login, the stored hashed password is retrieved and compared with the freshly hashed input password to authenticate the user. Another real-world application of password hashing and security practices is in online e-commerce platforms. Online retailers employ password hashing to protect customer accounts and ensure that sensitive information such as credit card details is safeguarded. By hashing passwords, these platforms enhance security, preventing unauthorized access and data breaches. In these examples, the implementation of password hashing and adherence to robust security practices play a vital role in safeguarding customer data and maintaining the integrity of the systems across the globe. Keep learning, stay curious, and I'll catch you in the next video.